Lesson 6, Optimization Problems. So the word optimize is when you want to find the best possible outcome. So usually with optimization problems we're finding maximums or minimums. So for example 1, 3 teams are traveling to a basketball tournament in cars and minivans. Each team has no more than 2 coaches and 14 athletes. 4 team members can go in 1 car, and minivans can take 16 members. No more than 4 minivans and 12 cars are available. The school wants to know the combination of cars and minivans that will require the minimum and maximum number of vehicles. Create a model to represent this situation. So we want to find how many vehicles we have. So let's let M equal minivans and C equal cars. And we know that we can't have half of a car, so M is an element of the whole numbers and C is an element of the whole numbers. So first part, they can have no more than 2 coaches and 14 athletes. So that's 1 team. So that 1 team can have 16 people in it. But there's 3 teams, so let's find the number of people. So number of people would be 16 times the 3 teams. So we have 48 people altogether. Just keep that in mind. So each car can take 4 team members. So 4 people times the car, and each van can take 16 members. So 6 for the minivan. And this is either going to be less than or equal to 48, which is the total number of people. Now, there's no more than 4 minivans allowed. So we know for our second function, it's going to be M is less than or equal to 4. And there's 12 cars available, so we know C is less than or equal to 12. So these are our 3 functions. So let's decide that our x-axis is our minivans and our y-axis is our cars. So let's plot our second 2 lines first because they're easier. So this one is M equals 4. We know that it's going to be a solid line, and because it's an element of whole, it's going to be discrete. So we're going to go to M is 4. So 1, 2, 3, 4. So right here we have a straight line going up and down for all M's equals 4. And we want to shade to the left. So I'm going to shade it after because it doesn't look very good on the iPad. Let's do our second. We have C equals 12. We know that this is going to be a solid line, and again it's going to be discrete. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we want it to be less than, so we would be shading below. The last one we have to find is our 4C plus 6M equals 48. So let's just give it a little bit more room here. So let's find our C-intercept. We'll make M 0. So 4C plus 6 times 0 equals 48. Divide by 4, and C is equal to 12. So we have a point at 0, 12. So right here. And to find our M-intercept, we'll make C equal to 0. So 4 times 0 plus 6M equals 48. Divide by 6, and M is equal to 8. So we have a point at 8, 0. right there. And we know that it's a greater than or less than or equal to sign, so it's going to be solid. And we are going to shade. So we don't know where we're going to shade, so let's just find a test point. So let's test 1, 1. So 6 times 1, or 4 times 1 plus 6 times 1 is less than or equal to 48. 4 plus 6 is less than or equal to 48. 10 is less than or equal to 48. So we would shade below. So remember, this is stippling. So the place that's contained would be this area. So it should look something like this. So we want to optimize our situation. So the optimization will be the place where the lines intersect. So we have an intersection here, and we have an intersection here. The first intersection at 0, 12 is going to be our maximum number. And we can find this by plugging it into our equation for the number of people, or to find the number of vehicles. So we have 4 times 12 plus 6 times 0, and this equals 48. So the maximum solution to get all of the people would have 12 cars and 0 minivans, so 12 vehicles altogether. The minimum will be the intersection as well. So that means that we get all of the people in with the minimum amount of vehicles. So minimum is at 4 and 6. So 4 times 4 plus 6 times 6. 4 times 4 is 24, plus 24 is 48. So we have all the people, and we're only using 4 plus 6, so 10 vehicles. So our maximum amount of vehicles used would be 12, and our minimum amount of vehicles would be 10 to get all of the people there. Now we're going to write an objective function. An objective function is an equation that shows what you want to optimize. So we want to optimize the vehicles. So we're going to let V equal number of vehicles. So V equals, and we're adding together cars plus minivans. So this is our objective function. So all in all, to find the answer, we're going to add our cars plus our minivans. So for this one, we'd add 12 plus 0 and have 12 vehicles, sorry. And this would be 4 plus 6, which is 10 vehicles. So this is our objective function, and it's finding what we want to do. Example 2. A refinery produces oil and gas. At least 2 liters of gasoline is produced for every liter of heating oil. The refinery can produce up to, that's supposed to say 9 million liters of heating oil and 6 million liters of gasoline each day. Gasoline is projected to sell $1.10 per liter, and heating oil is $1.75. The company needs to determine the daily combination of gas and heating oil that will produce to maximize revenue. To create a model to represent this situation. So we're going to let H equal heating oil and G equal gasoline. Because you can have decimals and 0.5 of a liter, this is going to be an element of R, and so will this. So everything will be continuous. So first, let's make up our sentences. So up to 9 million liters of oil. So we know that H is less than or equal to 9 million. I think there's one more. Yeah. So 9 million liters. So if we were to graph this, we'd graph H equals 9 million. So if this is our oils, the heating oils, and Y can be our gas, and let's go up by millions. So we want a line at 9 million. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to draw a horizontal line for 9 million. So H is less than or equal to 9 million. So we know that this would be a solid line because of less than or equal to. We know it's continuous. And it's less than, so we're going to be shading to the left. But I'm not going to shade on the iPad because it looks silly. Okay, now we know that they have up to 6 million of gas. So gas is less than or equal to 6 million. So we want to graph G equals 6 million. We know it's a solid line. We know it's continuous. And because it's less than, we want to shade below. So there is our next line. G is less than or equal to 6 million. And last, the question says there's at least 2 liters of gasoline for each liter of oil. So we know gasoline is bigger than oil 2 times. So 2 times the oil is equal to the gasoline. And it's at least. So it's going to be at least that number. So we want to graph G equals 2H. G is like our Y. So we're going to put it into Y equals mx plus b. So G is equal to 2H. So our intercept is 0, and we're going up 2 over 1. Up 2 over 1. Up 2 over 1. And it's a greater than or equal to sign, so it's going to be solid. It's continuous. And we'll pick a test point to figure out where we're going to shade. So let's pick 1, 3. So 3 is greater than or equal to 2 times 1. 3 is greater than or equal to 2. This is correct, so we'd shade below. So we were shading below. For the yellow or orange, we were shading to the left. And the red was shading below. So the place that overlaps is right here. And the way it should look is this. Oh, sorry, I said below. This one should have been shading above. I wasn't paying attention about where 1, 3 is. 1, 3 is above the line, so you should have been shading above. So the section that has all parts is right here. So anything in that area, you will be able to satisfy the equation. The company, however, wants to maximize. So if you look here at the point where all of the lines intersect, or the maximum intersection is, it's 3 and 6, which means our heating oil is 3 and our gas is 6. So we're going to plug that into all of our equations. And remember, these are in millions. And it checks for all of them. Now we need to find the maximum revenue. So we need to find our objective function. So we're going to let R equal our revenue. So R is equal to, we have gas and oil, or heating oil. We know that the heating oil is 110. And we know that the gas sorry, that I had gas is 110. Oh my goodness. I took all of this off and I couldn't see it anymore. So gas is 110 and heating oil is 175. So we have 110 times the gas. So we're going to find our maximum revenue by plugging it into this equation. So R is equal to 110 times gas, which we know is 6 million, plus 1.75 times, we know there's 3 million. So R will be equal to 660,000. So 6,600,000 plus 5,250,000. So altogether should be $11,850,000. So that is the maximum revenue.